In a second, I'm going to get into section 5.4. It's a word problem section, but it really is a friendly section. It's the first short section we're going to have in chapter 5. And if you just don't freak out that we're doing word problems, you should do really well with these. If you did well on the running and boating problems from a few chapters ago, these are way easier than those. So if you mastered those, you should master these. And even if you didn't master those, these are flat out easy problems. They're the nicest word problems that we get this whole semester. So don't be too intimidated by them. I just wanted to review a little bit from 5.3. So I'm going to make up 3 problems. Just to review. So I'm going to make up problems that highlight each of kind of the styles of tables that came up in section 5.3. So for each problem, I'm going to write a function. And I'm going to make a table of values and sketch a graph. So here's the first problem. Immediately when I see an x squared as the highest exponent, the graph is going to be a parabola. That's all we're graphing in this chapter, so we don't have to worry about anything else. I know I want to get a table. I want my calculator to help me out with the table. And this is the style of problem where I have to use the formula to get the numbers in the table. When there's 2 x's as opposed to 1, you have to use the negative b over 2a part of the quadratic formula to figure out your started table. So the b should be negative 20, the number in front of the x. So I'm going to go negative b. So negative, and then b is negative 20. And then over 2a is 2 times 5. So this is going to give me 20 over 10, which is 2. So when I go to sketch my graph, the numbers I'm going to need to see are numbers that are centered, that 2 is in the center of. So I found 2 on the x-axis. I made a couple of numbers to the left, found a couple numbers to the right. My starting table for this is going to be 0, 1, 2, 3, and 4. Chances are that I'm going to have to do some strange things with my y-axes because the y's are probably not going to fit real well if I increment by 1. So I'm holding off putting numbers on my y-axis till I do my table. So I'm going to get my table going. I'm going to go mode 7 for table, enter 5x squared minus 20 x minus 6, start at 0, end at 4, step 1. Oh, yeah, and I figured this much. So next to the 1, I get negatives. Next to the 0, I get negative 6. So I get the point 0, negative 6. 1, I see negative 21. 2, I see negative 26. That's going to be my vertex. 3, I see negative 21. And 4, I see negative 6. So these are just the y values that correspond to the x values. I'm going to plot the points. And on my y-axis, I'm going to increment by 5s. So I'm going to go negative 5, negative 10, negative 15, negative 20, negative 25, and negative 30. And then the best I can, I'll plot these points. So 0, negative 6, 0 is on the y-axis down 6, and then 1, negative 21 is, about here. 2, negative 26, I'll say is about there. 3, negative 21, and 4, negative 6. So the graph looks something like this. Again, if I put little arrows at the end of my parabola, that's probably nice. And I said label the vertex. So mostly the problems are easy if you can get this x column down, because that's it. Once you get the x column down, my calculator does everything else for me. So it's going to be differentiating between the styles of problem to know your starting table. And so in this first problem that I made up, there were two x's. When there's two x's, to know the number to get the numbers for my x column, I have to use a formula. The next two styles of problems, I can just look at the problem and know what the starting table is. So this is a new problem, not from the handout, just something I made up. And immediately, when you see there's only one x and there's no parentheses, you should know the starting table is -2, -1, 0, 1, 2. This is like the first group of problems. When there's two x's, you have to use the -b/2a formula. When there's only one x squared term and not another x term, I use the -2, 1, 0, 1, 2. And let me do that table real quickly here. So now, mode table -3 alpha x squared plus 7. Start at -2, end at 2, step 1. So next to the -2, I see -5. Next to the -1, I see 4. Next to the 0, I see 7. Next to the 1, I see 4. Next to the 2, I see -5. And again, I can look at my y's and tell you if I picked a good starting table because of the duplication in the y's between the top and the bottom of the table. And now I'm just going to plot these the best I can. It doesn't have to be that accurate, but I can increment by ones now on both axes, I think, because I can get up there. I think on the test there's going to be kind of graph paper on the test for you to use, kind of like I did when I did the lecture. So I'm just going to plot the points the best I can. So -2, -5, -1, +4, 0, 7, 1, +4, and 2, -5. So the negative in front of the x squared made the parabola flip upside down, made the vertex be a maximum point. So I did make a table of values. I sketched a graph, and I'm going to label the vertex. This vertex is the point 0, 7. So there's one more style of problem that we had in section 5.3. So the third style that were presented in the section had the two x terms. The first style had the one x term, and the middle style when we did section 5.3 was the one that had the parentheses, like something like this: f of x equals to 2 times x minus 5 squared minus 3. So if I was doing this one, I immediately know I can get a starting table easily, because all I do is I take the number inside the parentheses and I change its sign. So the number inside the parentheses was -5, I change its sign. So my table is going to be 3, 4, 5, 6, 7. Once I find 5 on the x-axis, I go left and I go right. So this is the third style. So 2 of the 3 styles of problems, the tables, the x values come for free. The other one I have to use the formula to get started. Alright, so let's do this. Mode 7, 2 times parentheses alpha x minus 5 squared minus 3. Start at 3, end at 7, step 1. And I see 3, 5, 4, -1, 5, -3, 6, -1, and 7, 5. So that's, again, I can tell I've got a good table because of the duplication in the y column. If I don't get that duplication in the y column, then I probably haven't picked a nice set of x's to start. And then just, the best I can, I'm going to plot the points. So 3, 5, 4, -1, 5, -3, 6, -1, and 7, 5. and they should, point out a U. That's horrible. And I see this all the time. It's not supposed to be a V. I'm supposed to really emphasize that it's supposed to be more of a U than a V. But, oh well, it is what it is. If your drawing looks like a V and you're attempting to make a U, I'm not going to take points off. So that's everything I wanted to review from section 5.3. So immediately, when you're asked to graph a parabola, you have to look at the problem, and it's going to help you decide the starting table. Once you get the x column, your calculator will spit out the y column. It's not terribly hard to plot points, and the vertex is always set up in the middle of the x column. You have to know the axis of symmetry and the maximum or minimum values, but that I did so much of. I hope you felt good about it. So the nice thing about section 5.4 is that even though the problems when you read them might seem wildly different from each other, every single problem is essentially the same problem. Even though they have different words, structurally to me, they're all the same. In that, as I read through every problem, somewheres in the problem, in the word problem itself, is an equation, and by my experience, I know that the graph of the equation is going to be a parabola. So, like in problem 2, I see the t squared. I know I'm going to get a parabola. In problem 4, it's a similar kind of question. I should kind of spit out on me here. When I should be negative 4.9 t squared plus 29.4 t. Again, I know that's going to be a parabola because the highest exponent is a squared. I'm using different letters because the letters have some meaning in this problem. In problem 6, same sort of deal. I see a squared term. So for every single problem, somewheres in the equation, somewheres in the wording, I see an equation. And very specifically, a lot of what the wording does is just describe the letters in the equation. So as I read through problem 2, it talks about an object being thrown up into the air, and it gives me an equation, and an equation that would graph to be a parabola. And very specifically, it says the h in the equation stands for how high the ball is at any time, and the t in feet. And the t in the equation stands for how many seconds after it's been thrown. So I'm going to make a table of values to help you understand this question. So I have an equation, height, so this x column I'm going to call the time, and the y column I'm going to call the height of the ball. Because to the right of the equal sign, that's kind of where our x's normally were. The letter in place of the x is a t. It stands for time in seconds. And the letter to the left is where our y goes, and it stands for the height. Let me make a table and then explain each point and then show you how those points will help you answer the question. So if I'm making a table of values for this, because I see 2 letters to the right of the equal sign, I know that my table, if I'm going to sketch a graph, I have to use the negative b over 2a formula, where the a is the number in front of the squared term, so it's negative 10. The b is the number in front of the first power term, which is 80. So negative b is going to be negative 80. 2a is going to be 2 times negative 10. That simplifies to be negative 80 over negative 20. And that reduces to positive 4. So I'm going to even sketch a graph. I really don't have to sketch a graph, but it might help you understand the problem. So in order to sketch my graph, I need to know my x column. So I'm going to find 4 on the x-axis, and my table is going to go 2, 3, 4, 5, 6. So it means then the 2 stands for 2 seconds, the 3 stands for 3 seconds, the 4 for 4 seconds, the 5, and the 6 for 5 and 6 seconds. Let me fill in the y's. So I'm going to go mode 7 and then negative 10. I can't do t's, I'm stuck with the x's, so negative 10x squared plus 80x plus 12. Start at 2, end at 6, step 1. And so the first number I see is, I'm going to fill the numbers in and then tell you what they represent. So 132, 162, 172, 162 again, and 132. So I have a bunch of points, and what each point represents is a time and a height. This point means at 2 seconds, the object is 132 feet high. This point, second point, means at 3 seconds, the object is 162 feet high. The third point, at 4 seconds, the object is 172 feet, and so forth. Just by having this table in front of me, I can tell the vertex is a maximum point. That's a good thing, because if the vertex is a maximum point, the y-coordinate of the vertex is the maximum y value. The maximum y value stands for the maximum height. If I look at the question that's being posed, I might be able to answer the questions without sketching a graph. Ultimately, we don't really need to sketch a graph, but I'm going to anyways. To sketch my graph, I don't even know how I'm going to do my y-axis by 50. I'm not even sure that that's a good number, but it's good enough, I guess. So first point, 2 seconds, about 132 feet, the best I can estimate that. 3 seconds, 162 feet. 4 seconds, 172 feet. 5 seconds, 6 seconds. So if I do this and sketch the graph, I see the path of the ball, or the object, and this right there, that's its high point. Each one of each position, where it is at, it kind of shows both its time and its height. The x-coordinate is the time, the y-coordinate is the height, and I can see when I graph this, the vertex is going to contain my answer. That's going to be the case for every single problem in section 5.4. The equation in the problem is going to be a parabola. The questions that are going to be asked can be answered if you understand what the x and the y coordinates of each point mean and you know where the vertex is. So I don't need to do any algebra to answer any of these questions, really. My calculator is going to kick everything out to me if I get a nice little table. So if I look at the question, when does the object reach its maximum height? Well, it does it at 4 seconds. It reaches its maximum height of 172 feet. So I'll say at 4 seconds, it reaches its maximum height. Part B, what is the maximum height? The maximum height is 172 feet. I know that answer is correct because the vertex is a maximum point, and so I know there's not going to be a y that's higher than 172. When the vertex is a maximum point, it's the largest y value, and that means the y values here are the height of the object, so it's the maximum height. And I'm completely done. The nice thing is every single word problem in this section, even though they might talk about something completely different than throwing an object in the air, they're going to solve exactly the same way. I'm going to make a table of value. I'm going to understand what the x's and the y's of each point mean. I'm going to make a table of values. In that table of values is going to be the vertex. Knowing the vertex is going to help me answer the question. 4 is essentially the same problem. I made a question about a golf ball, but it's really similar. And the equation, when I blew up the font, kind of got spread out, so I rewrote it here. And this is real similar in terms of how the equation is written. This equation I wrote in function notation as opposed to non-function notation. But that shouldn't slow me down. immediately when I see an equation, I have to understand what the letters mean. The H is going to stand for the height in meters this time, and T is going to be the time in seconds. So just like the last problem, I'm going to make a table of values to help me understand the question. The letter to the right of the equal sign is where my x's go. That stands for T, stands for the time in seconds, so I'm going to put time. And then the letter to the left of the equal sign is what the y stands for, and the y stands for the height in meters. So it's the same kind of names for my x's and y's, other than this height is in meters as opposed to feet. Again, I see two letters, so I know I have to use the negative b over 2a formula. The a is the number in front of the squared term, so the a is going to be negative 4.9. The b is the number in front of the first power term, and I'm going to have to pull my calculator out here. So I'm going to use the negative b over 2a formula, which is going to be negative 29.4 over 2 times negative 4.9. And let me just do that because I don't care to do that in my head right now. I'm going to hit the mode button, hit number 1 to just do a computation. I'm going to go fraction, negative 29.4 over 2 times negative 4.9. And that gives me 3. So that tells me, so this equals to 3. That helps me get started. Don't even need to make a graph if I don't want to, but I certainly want to have a table. And the numbers in my table, 3 is going to be in the middle of the x column, and I'm going to just have 1, 2, 3, 4, 5 for my table. So 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. I'll be able to tell you the height of this golf ball at every second for the first 5 seconds that it's flying if I finish up my y's. So I'm going to finish up my y's by going mode, table, and then negative 4.9. I can't use a t on this calculator. I'm stuck using x's. So x squared plus 29.4 x, start at 1, end at 5, step 1. So this says at 1 second, the golf ball is at 24.5 meters high. At 2 seconds, the golf ball is 39.2 meters high. At 3 seconds, it's 44.1 meters high, which is about 125 feet or so, I guess. At 4 seconds, it's starting to go down again, so the vertex again is a maximum point. That's good. So I can see at different times the height of the ball. 1 second, 24.5 meters, 2 seconds, 39.2 meters, 3 seconds, 44.1 meters, 4 seconds, 39.2 meters, 5 seconds, 24.5 meters. So the vertex is a maximum point. The questions are asking things about maximums. That's good because the vertex is a maximum point. So it's going to help me answer the question even without sketching a graph. If I sketched a graph, it would look a lot like the graph in my last problem. It's got a parabola that opens downwards. But I don't even need to sketch the graph to answer the question. I understand that this 3 in this column, because it stands for a time in seconds, is 3 seconds. This 44.1 in the height column stands for height in feet. And if I answer the questions, at what times does a golf ball reach its maximum height? Well, it's at 3 seconds. What is the maximum height? 44.1 meters. So there's no factoring, there's no solving for x. It's just basically producing a table and and understanding what the x's and y's in the tables represent. It's all that there is for every one of these problems, even though they might start talking about something a lot different than an object or a ball being hit. 6 is another, is a baseball problem as opposed to a golf ball, but same sort of thing. If I look at the equation in 6, it has the same letters. I'm getting used to these letters, and it very specifically, as I read through it, it tells me the h stands for the height in feet. That's going to be my y's because it's to the left of the equal sign. The x's are going to be to the right of the equal sign. That's the time in seconds again. So this talks about a guy hitting a bloop single, and his baseball, it it probably doesn't get too high if it's a bloop single in baseball. The question is, when does it reach its maximum height, and how high does this baseball go? Easy enough question, because the t it's in the x position, so it represents the time in seconds. The h represents the height of his ball. Let me figure out how high it goes. This one's written sneaky because the a and the b are reversed, because the a is always the number in front of the squared term. The b is the number in front of the first power term. So the a and the b are written backwards, and it's designed to catch you, I guess. Because if you just blindly take the first number and call it a and the second number and call it b, that's not always the case, because the a is always associated with the squared term, the b is associated with the first power term. So if I use the negative b over 2a formula to help me get started, negative b is going to be negative 64, 2a is going to be 2 times negative 16. I can do this one without my calculator. This comes out to negative 64 over negative 32, which is going to be 2. So if I was making a graph, the number in the middle of my x column would need to be 2, and then so my numbers have to be 0, 1, 2, 3, and 4. And again, as I read this, it says the height of a single is described approximately by. So it's like not like you can take a picture and actually measure where the ball is. It's just an approximation. Usually mathematical formulas that describe motion, that's what they do. They approximate. They can be off a little bit, but they're good estimates. So let me do this again. I'm going to do mode table 64 x minus 16 x squared, start at 0, end at 4, step 1. So this says at 0 seconds, right when the bat hits the ball, it's at 0 feet. That's probably not right, because the ball is probably a foot off the ground when he hits it, so it's just an approximation. At 1 second, the ball's up to 48 feet in the air. At 2 seconds, it's at 64 feet. At 3 seconds, it's going back down to 48 feet. And at 4 seconds, it's back down on the ground again. So again, I can tell the vertex is a maximum point because it contains the maximum value in this table. So when does the ball reach its maximum height? 2 seconds. What is the maximum height? 64, and then the units are in feet. And I don't have to sketch a graph. I just have to understand what the numbers of the vertex are telling me and confirm that the vertex is a maximum point if it's asking for a maximum value. I think the next few problems give me completely different scenarios. These first 3 problems were kind of the same. They're a ball being hit, golf ball being hit, a baseball being hit, an object being thrown in the sky. They all modeled a ball going up and down, but not number 8. Number 8 is completely different, and it's got lots going on in it that makes it hard. And immediately as I read this problem, it talks about the height in feet of or the depth, should I say, of water in a reservoir. So like Lake Pleasant is maybe a reservoir, and over the summer we pump water out so it gets shallower, and then in the winter, when the winter rains come in, it gets deeper. So the height of the lakes or reservoirs fluctuate throughout the year. If you're used to Los Angeles, there's lots of reservoirs around town, and same sort of thing. Their height fluctuates throughout the year, and usually our reservoirs, they go down in the summer and they go up in the winter. The question here is, how low did the water level get, and when did it get at its lowest amount? So I have to understand what the letters mean. The letter T is supposed to represent a month. So the T, which is in the X position, stands for a month. And the thing to the left of it stands for the height or the depth of how much water is in the reservoir. So So this reservoir almost dries out in the summer. Kind of maybe like Horseshoe Lake, if you're used to that. That thing goes bone dry in the summer. Or even Lower Lake Mary goes, if you're used to Flagstaff, goes dry in the summer. So I'm going to make a table and understand what each of the points in the table represent, because it's a little bit trickier, and answer the question. So immediately I look at the equation. There's a parentheses with one letter. I change the number in the parentheses, change its sign, and that's going to go in the middle of my x column. So when I go to do my table, the numbers I'm going to put are 5, 6, 7, 8, and 9, because I take the number inside the parentheses, change its sign, and then find it on the x-axis. And I've got a nice set of 5 numbers here. The vertex is going to be in the center. I'm going to graph this now, get some points. So mode table, 5 times parentheses alpha x minus 7 squared plus 3. Start at 5, end at 9, step 1. So it says, let me just spit out these numbers real quick, then I'll talk about what they mean. So 23, 8, 3, 8, and 23. So what each point gives me is a month and how deep the reservoir is. It says T equals 1 stands for January, T equals to 2 stands for February. This 5 in the T column stands for May. So this would mean in May, the depth, or how much water is in the reservoir, is going to be 23 feet. This 6 would say in June, the depth, the depth of the reservoir is 8 feet. This next one, 7, is the 7th month of the year, which is July. So T equal to 7 stands for July, because that's the 7th month. And then it says the depth is 3 feet. If I look at my vertex, the vertex is a minimum point, and that's good because the questions are minimum. It's low questions or minimum questions. So in the first 3 problems, the vertex were maximum points. The questions that were asked was how high did it get? In this question, the vertex is a minimum point, and the question being asked is how low did it get? So I can answer the question now. How low did the water get? It got to 3 feet. That's the least amount. And when did it get to that? In the 7th month of the year. And the 7th month of the year is July. Again, no algebra to do. It's just understanding the equation, what the letter in the x position is telling you, what the y's are telling you. And every one of these problems, the questions are going to ask, it's going to draw you to the vertex. It's either going to be what's the maximum amount or what's the least amount. It's going to be the maximum amount if the vertex is a maximum point. It's going to be what's the least amount if the vertex is a minimum point. So 10, completely different scenario from anything we've done so far, but still structurally the same way. So it says the following function can be used to compute the average score in a math placement test taken between 2000 and 2011. So it gives me an equation, and it tells me what I get out is the average score in a math placement test. And these letters, the T's, they stand for years. T equals 0 stands for 2000, T equals 1 stands for 2001, T equals 2 stands for 2002. So the letters to the right of the equal sign, the T, this time it stands for a year. What it gives me out is the average score on a math placement test. So I'm just going to write for the Y column. So every point on the graph, its X is going to represent a year, its Y is going to represent an average score in a placement exam. Let me do a table by doing the negative b over 2a, because there's two letters. So the a is going to be 1, the b is going to be negative 10. Negative b over 2a is negative 10 over 2 times 1, which is going to be positive 10 over 2, which is 5. So 5 is going to be in the middle of my x column. So I go 1, 2, 3, 4, 5, 6, 7. So the table I'm going to make is going to have 3, 4, 5, 6, 7. 3 stands for the year 2003. 4 stands for the year 2004. 5 stands for the year 2005. The number in the y column is going to be what the average score in the math placement test was during those years. So mode 7, again, I can't use the t because I don't have one. Start at 3, end at 7, step 1. So it says in 3, which is 2003, the average score in the math placement test was 63. 4, which stands for 2004, the average test score in the math placement test was 63. 5, which stands for 2005, the average score in the math placement test was 62. In year 2006, the average score was 63, and in 2007, it was 66 again. So I'm ready to answer my question. The vertex is a minimum point. That's perfect for answering lowest question. It doesn't ask me a maximum question or a highest question. When vertexes are minimums, they do well to answer what's the least amount. When vertexes are maximum, they do good, what's the highest amount. So in which year? The year that stands for 5. 5 represents 2005. What's the lowest average score? 62. I don't know if that's a percent, so I'm just going to leave it at that. I don't know how many points are possible. This question has nothing to do with reality. I just made it up. I have no idea how many points the test math placement exams are worth, and I just made up these numbers completely, but they seem to work okay. Last problem. Again, a completely new scenario. Gives me another function, and I'll write this function out. So it says t of m equals negative, I'm going to emphasize 1m squared plus 16m plus 2. There's not a 1 in front of the m, but I can assume it. As I read through the equation, it says this function can give me the average daily temperature for any month, the average daily high temperature for any month for a small town in Iceland. The m represents a month. 1 stands for January, 2 stands for February, 3 stands for March, 4 stands for April, and so forth. And the y is the average high temperature during that month. So the x column represents a month. The y column gives me the average daily high temperature. Let me figure out how my table is going to go. So I'm going to do negative b over 2a. The a is going to be negative 1. The b is going to be 16. Negative b over 2a is going to be negative 16 over 2 times negative 1. That's negative 16 over negative 2. That's 8. So 8 is going to be sitting in the middle of my x column. I think I can do the other numbers without making the little graph. It's going to be 6, 7, 8, 9, 10. 6 is going to stand for June, 7 for July, 8 for August, 9 for September, 10 for October. And the y's next to them are going to give me the temperatures during that month. So let me enter this, mode 7. I don't really need the 1 on my calculator, so I'm just going to go negative alpha x squared. You can put the 1 in, it wouldn't hurt it. Plus 16 alpha x plus 2. Start at 6, end at 10, step 1. Says in June, the average high temperature is 62 degrees. I'm assuming it's Fahrenheit. In July, the average high temperature is 65 degrees. In August, the average temperature is 66. It's cold in Iceland. In September, it's 65. And in October, the average high is 62. Again, I made this function up again. It probably has nothing really to do with the temperatures in Iceland. I just made something that kind of, had a parabola equation that we can use. So immediately, I can see the vertex is a maximum point, and that's good because it's asking the question is what is a maximum amount, and that's perfect. So which month has the highest average temperature? The 8th month of the year, which is August. What is that temperature? 66 degrees. So every single problem in this section, if you can just understand the equation, what the x's and the y's mean in the equation, and produce some sort of table, really you just need the vertex. If you understand if the vertex is a maximum point, it will help you answer maximum highest questions. If the vertex is a minimum point, it'll help you answer how low questions. So basically, all the word problems that you're going to do for homework are probably going to be a lot like these anyways, but you just need to just hone in on the formula, understand what the x's mean, what the y's mean, generate a table. Vertex should be sitting in the middle. That vertex is going to contain your answer. You just have to understand what the numbers in the vertex represent in terms of physical quantities. If you get that down, there's no algebra to do, and you can kick through the answers really quickly. All right, next section is another long section, but it's the last section for the chapter.